Hello everybody, and welcome to the Unit 4 0 period notes video. So with this one, if you're finding this, hopefully that means that you need to recover the Unit 4 section of Semester 1 for Algebra. And so this video will walk through the notes associated with that. And as usual, this will have the Delta Math sections listed that you should work with from it. Okay, so they're always listed under where the day is listed. If you need instructions on how to get to the Delta Math, if Unit 4 is your first one that you're joining us for, find on the same channel the How to Access 0 Period Delta Math video. All right, let's get into it. So, this was all about function notation, like so much function notation. And so, let's get into that. So, it says the graph of y equals f of x is shown below. Determine the value of x when f of x equals 0. So, let's make a few notes about function notation. The first thing that you should be aware of is where the x's are, where the y's are. So if something is f of x equals a, for example, this is the x, this is the y. Okay? So when it says determine the value of x, we're looking for this when the y is 0. Oops, let me fix that. When the y is 0. Okay? So when the y is 0, go ahead and look at your graph and find where y is 0. So here's the y-axis. Here's 0. There's only one point on it, and that is point B. Okay? So, that said determine the value of x. Well, what is the x value right there? If you look, the x value is -5. That means we could write f of -5 is 0. So in other words, for function f, when your x is -5, your y value is 0. Okay, so that's what that is saying. So get another one. So for this one, it says the graph of y equals f of x is shown below. According to the graph, what is f of -6? So in other words, they're saying, what is the y? I'm going to write this out in words. What is the y when x is -6? So let's go and find where -6 is for the x. So this is the x-axis. Let's go to -6. Right here at D. Notice that point D, y is 0. So we can say f of -6 equals 0. Okay? So in other words, f of -6 is 0. Okay? All right, there are two for y'all to try. That one and that one. So go ahead and pause the video, try them, and then unpause when you're ready to check. All right, so it said f of -4. So go to -4 for the x. We're looking for the y. So go to -4. There's the y up there. So we could say f of -4 is, looks like that is at 4. Okay, so that was that one. Then let's try this one out. So the graph of y equals f of x is shown below. Determine the value of x when f of x equals 4. So f of x equals 4. That would mean that this 4 is a y. So go to where your y is 4. There it is. Go up along this one and see what it is. Point B. And looks like that x value is -6. So we could say x is -6. In other words, f of -6 is 4. Okay, so that's what's up with those. Okay, then we had some average rate of change to do. So they gave us some graphs. There were all these like graphs, okay? And what they're saying is the function y equals f of x is graphed below. What is the average rate of change of the function on these intervals? What they are giving you is they are giving you x1 and they're giving you x2. Now remember, your formula for the average rate of change is just the slope formula. y2 minus y1 over x2 minus x1. Well guys, we have x1. So that's -9. So if you go on your x-axis to -9, so right here, you can go find what y should be. So I want you to notice that is -9 and -10. Looks like those are going by 2, so -9, -10. So that is our x1, y1. Then x2 was 1. So 1 is here, and then go down, that looks like that's at -6. So 1, -6 is x2, y2. Then let's plug them into here. So that'll be -6 minus -10. Divide that by 1 minus -9. So that's -6 plus 10, so that'll be 4 over 1 minus -9, so that's 10. 4 over 10, reduce that will be 2 over 5. Okay, so that's how you do those when they are a graph. So basically, those are your two x values. Go and find your y values, and then just plug it in. All right, let's do one more together. So, there it is. We're finding over the interval -9 to -4, so that's our x1, our x2. I'm going to go ahead and label those as x1 and x2. Okay, so I'm going to go circle them. So -9, go here, -9, down to here. So -9 looks like that's -16. So that's x1, y1. Then -4. -4 is at -4. There's your there, trace it over. That's x2, y2. That makes it -4. Because remember the formula is y2 minus y1 over x2 minus x1. So that makes it -4 minus -16. Divide that by -4 minus -9. So that makes it 12 over 5. Okay. And we're done. Because 12 can't be divided by 5. They don't have anything in common that they could reduce. Alright, there's one for y'all to try. For you guys to try these two. Okay, so pause the video, try these two, and then we'll see how we do. Alright, so for this one, looks like 5 to 7, so x1, x2. 5 was right here, so that was 5, 4 was x1, y1, and then 7 was right here. That looks like that's at -6. So 7, -6 was at x2, y2. So that makes that -6 minus 4 divided by 7 minus 5. That makes it -10 over 2, which is -5. Hopefully you get that one. Big thing that I've seen students struggle with in the past is flip-flopping one of these, where you basically end up with y2 minus 1 over x1 minus x2, where you accidentally flip that around. So be careful with that. Make sure your points always line up with the y is on top of the x. So see how this y is on top of this x, and this y is on top of this x. It's a good way to check it. Okay. So for this one, hopefully you had something like this. Looks like -7 was at, so these are going by 5, so -7, 5. For x1, y1. -2 looks like was up at 25 for x2, y2. That makes it 25 minus 5 divided by -2 minus -7. That makes it 20 over 5 equals 4. Okay, cool. Alright, let's look at this last day 3 part. We might actually knock this out in one video. Look at this. All right, so for this one, we have interpreting some graphs and making some graphs. I don't know, we might make it in this video, we'll see. This one says, one spring day, Dalvin noted the time of day and the temperature in degrees Fahrenheit. During that time, the temperature rose, stayed steady, and fell at different rates. On the set of axes below, Dalvin created a graph of temperature over time. Okay, so here's time. Looks like this is like 6 a.m. early in the morning, noon, 6 p.m., 12 midnight. So it looks like it's probably going by about ones, because this would be 7 a.m., 8 a.m., 9 a.m., 10 a.m., 11 a.m. Yeah. So the question is, how hot was it when the temperature held steady? So here's time, here's temperature. Well, look for when it held steady. That would mean it's a flat line. So like right here to right here, it was steady during that whole time. Looks like from about 12 o'clock or so to about 6 o'clock or so. But I want to know how hot was it. So what you got to do is trace your line over. Looks like I'm getting 63 degrees Fahrenheit. Okay. And so that's how hot it was when it held steady. It's just 63 degrees outside. Okay, so that's how you'd interpret that graph. All right, let's do another one, then there's some for you to try. All right, Tariq left his house and drove to the store. He stopped and went inside. From there, he drove in the same direction until he got to the bank. He stopped and went inside the bank. Then he drove home. The graph below shows the number of blocks away from home Tariq is X minutes after he left his home until he got back home. Okay. I'm going to zoom in so we can see this one a little bit easier. So, for this one, it wants to know how long was Tariq in the bank. So, for the bank, was that his first stop or his second stop? It says he left his house and drove to the store. Okay, so he must be driving. Then he gets to the store. Then he stays in the store. Then he driving. And then he must be in the bank. So that must be that top part because that was his second stop. So let's try to figure out how long he was in there. If it'll let me zoom a little bit more, that would be great. Here we go. So, looks like he got to the bank right about, here. And he left the bank right about there. So, I'm going to do my best to just trace it down. So that's about 14 minutes or so. I'll trace this one down. And again, we're estimating a little bit. That's about 10 minutes. So it looks like he's only at the bank for 4 minutes. Okay. Now, there's a couple here, this one and this one, for you to try. Okay? So I want y'all to try those two. And then when you're ready to check them, start watching the Unit 4 0 period part 2 video.